Lesson 7.2, Modeling with Polynomials. In this video, we will create scatter plots and predict the type of polynomials that best fits the data. Then use a graphing calculator to determine regression equations and how well they model the data. Why did the chicken cross the road? To get to the idiot's house. Knock knock. Who's there? The chicken. Alright, vocabulary. Regression equation is a function that models the relationship between two variables in a scatter plot. Coefficient determination. Coefficient of determination. Issues reading that one. The R squared measures the strength of the relationship between the original data and its regression equation. The value range from 0 to 1, with a value of 1 indicating a perfect fit. Part A. Create a scatter plot of the data. Predict the type of polynomial that best fits the data. Explain your reasoning. Part B. Use a graphing calculator to determine the regression equations for the data from problems 3 through 6. Round the decimals to the nearest thousandths. Sketch each regression equation on the coordinate plane with the corresponding scatter plot. How well does each regression equation model the data? Explain your reasoning. Number 3. The table of values represents the temperature of 2 liters of water in a tea kettle over time as it set to boil and then cools down. Alright, so we're going to go ahead and plot these points. Alright, so I went ahead and numbered the graph for the axes. So we're going to plot each of the points and then we'll look at the graph itself. Alright, so now that we've graphed the points, or plotted the points, we want to take a look at what we see here. Okay, so I'm going to write down what I notice. First thing I notice is that it begins and ends the same, which means that it is even, right? Another thing that I notice is that minimum it's a quadratic, or the other thing I notice is that it has one extrema. So minimum it's a quadratic. It could be quartic, it could be some even function, but for the most part it looks like it goes up, comes down. It is a quadratic function. So we're going to go ahead and call this a quadratic function, and that's what we're going to target when we do our regression equation. So that's part A. Part B is to figure out the regression equation. Now, in a different video, I show you how to use the graphing calculators to do this. In this video, I'm going to show you how to use Desmos to do this. So we're going to go ahead and pull Desmos up. Okay, I already typed the data values in. In order to see the graph, we want to go to the little wrench on the right side of the Desmos, and in there we want to change this to match what we have on our graph itself. So our x goes from 0 to 100, and our y also goes from 0 to 100. So now you see what we see on our other screen, or on what we graphed a minute ago. So in Google Classroom, I'm going to have this posted for you guys so you can add it to your repertoire for Desmos. So make sure when you do open this in Desmos that you save it afterwards. On here, in the tables where you're going to put your values, okay, and then you'll notice the very first thing in the list is the regression for a linear function. Then you've got a quadratic function. Then you have a cubic function. Then you have a quartic function, degree 4. And then you have a quintic function, and then a function that is to the 6th power. For the most part, 5 and 6 we don't use. Okay, occasionally there's something that we'll use 5 and 6 for, but those are real extreme, and for the most part we're not going to use those. So we're really going to stick between 1 through 4. Those are like the targeted ones that we'll be using. Now we just talked about the fact that ours is quadratic, so we're going to be looking at the x squared. So in the quadratic part here, you'll notice what a, b, and c are, and you'll see the r squared. R squared is equal to 0.7593. A is equal to negative 0.0782652. B is 4.63194, and C is 19.0962. We only need 3 decimal places, and we're going to use those to write our regression equation on our paper. So our regression equation is going to start with f of x equals, and then we're just going to write down the values that I just read off to you. Negative 0.078 x squared plus so 4.63 x squared x plus 19.06. And then the last part of this is to determine or to tell how well the regression equation models the data and explain our reasoning. Since r squared is equal to 0.76, the regression equation is acceptable. It's not perfect, it's not the best, but it's acceptable. We can use it to model our graph. So along with that, we want to actually draw the graph. That was part of what we were supposed to do. So I'm going to go back to Desmos for a minute. And on Desmos, once you've already got this plotted, you can click on the circle, and it gives you the exact shape of the line that's graphed. From that, you should be able to get an estimated graph of your own. Just by, you can even trace the line, right? I would target the highest point, which is like 29 and 88. I would target the start point, which was like 0.19, and then some low point on the other side, where ends is at like 63, right about 63 on the line. Okay, so from that you should be able to then draw it yourself. So let's go back, and we're going to try to draw this ourselves. So I said start somewhere around 19. The max was at about 30.88. It's like right up here somewhere. And then 63.0, which is somewhere right around down here. So that'll get the approximate shape of the graph. Notice that it doesn't cross any of our values on the graph. That's why it's only acceptable. You really want things to cross multiple values for it to be a really good fit. All right, well with that, I'd like you to try number 4 on your own, and then you can unpause the video and check and see how you did. Although before you do pause it, let's just take a quick second and talk about how I got my numbering on the last graph. What I do is I look at the values in the table, and I know that there are 20 lines across the bottom and 20 lines across the top. So I always start with 0 because my graphs all start with 0. And in this case, across the bottom, we need to end at 50. Okay, so if I go by 5s on every other line, I should get to 50. If going upwards, it looks like we max out at like 24, right? 25, right in there. So easily done. We can go to 30. And again, if we go every other line by 3s, that's going to get us to 30, because again, there's 20 lines. So if you're going every other line, you're really only going 10 spots. So that's how I would get the numbering for this. So go ahead now, get your numbering, do all the work, unpause it, and see how you did. So a lot just happened here. First thing you'll notice is that it begins and ends opposite. So that means that we have an odd degree. There are 2 extrema. So that means that the minimum we would have is a cubic function. So you'll remember that I went back to Desmos and looked up the cubic function information in order to get the regression equation. And then along with that, we noticed that r squared is 0.87. So the regression equation is a good fit for the data. You'll notice that last time we had said acceptable because it was 0.7. This time it's higher than 0.85, which anything higher than 0.85 I would say is a good fit. Anything between like 0.85 and 6 is acceptable. And anything less than that is starting to get questionable as to whether it's good or not. So with that, that's how we graph scatter plots and create regression equations from the data.